In a previous lecture, we had a very brief look at matplotlib talking about its basics. In this video, we'll cover a more advanced syntax that will open up new possibilities of how we can plot our data. And so in the previous lecture, we used the PLT interface for our plotting. So we called on the pyplot submodule the .plot and passed to that some data. And then with plt.show, our data was plotted. One quick note, the plt.show was necessary when we worked in a script, but here working with Jupyter, we don't even need the plt.show, so the plot will display regardless. And so using this interface, we don't have access to any plot objects. And this is perfectly fine for doing smaller stuff, but if we want to combine multiple plots, either in one spot or separately, then things can get messy if we cannot reference the actual objects. And so the syntax that we will switch to is actually already used internally. So when we call plt.plot, what happens is that internally it calls on some hidden access object the same plotting method. And so using this syntax, we don't have access to this hidden access object, which we would like to make everything more manageable. But before we go into how we can do that, we should first talk about what even is an axis and how it relates to a plot. And so when we talk about a plot in matplotlib, we usually mean the figure object. And this figure object is the top level container that can then contain multiple axis objects or subplots. And then each subplot or axis object has axes, so with I, an x-axis and a y-axis. And when we plot our data, that usually happens on these subplot or axis objects. So with our previous syntax, this hidden axis object was some subplot that was created internally, but hidden from us. And then when we called plt.plot, this subplot was used for plotting. So now, how do we explicitly create a figure and subplot objects? And for that, we have two options. The first option is that we call plt.figure, which returns us a figure, and then we can add to this figure subplots by calling on it the function add subplot. And to the function we pass 111. But actually it's not 111, but it's 111. And it indicates that in a 1x1 grid, we place the subplot in the first spot. So if we run it, then we have a 1x1 grid, and then in the only spot we place our subplot. So the general workflow is that we always create figures and then add axes or subplots to that. And things get more interesting when we have not just a 1x1 grid, but in this case here we have a 2x4 grid. So again, first we create our figure, and then to our figure we add subplots, or rather a single subplot in this call, and then the grid should be 2x4, and here we place it in the first spot. So this will be this subplot here, and then in this line we place the subplot in the fourth spot, so here, then here in the sixth spot, and here in the last spot. And we can already see that this syntax gets quite repetitive, because we have to explicitly initialize every plot in our grid. And so if we are sure that we want the whole grid to be filled with subplots, which is usually the case, then there's a second option, which is in my opinion also generally better. Because here we can just call in a single line plt.subplots. So we're not calling first figure, then plt.figure, and then add to that single subplots. But in one call to subplots, we get a figure and multiple axis or subplot objects. And we can again specify how many rows and how many columns we want in our grid. So here just 1x1. And of course we can also create multiple. So here again 2x4. And this syntax even has a second advantage, because the type of the axis object that is returned is a numpy array. So we have a lot of options of how we access these subplots. And they're not scattered around in random variables, which would be the case here. Okay, so we have a lot of plots, but the problem is that the ticks of the axis are overlapping. And to fix that, we can call on the figure the tight layout function. And this will make sure that none of the tick labels are overlapping. But still the plot looks a bit off, because now the plotting windows are very squished. And so for that, we can change the size of our figure. And we do that by passing fixed size as an argument to the subplots function. So here we specify 10x4, and now we have a proper grid of plots or subplots. But still we're missing a lot of stuff, so the plots don't have titles and also no axis labels. So let's start with a single plot again, and the syntax here is quite straightforward. So we call on our subplot, so the AX, the different setters. So for example, we can set a title with set title, and to that we pass a string, the same for the y-axis label and the x-axis label. And we can also pass limits for our axis ticks. And then when we're working in notebooks, we can simply type the variable of our figure to display our figure. So now we can see we have the title and example axis and also axis labels. And now you might be thinking, don't I already know how to set titles? Because we also covered that in the previous lecture. And yes, of course, but the difference is that when we had the other syntax, we didn't call set and then title, but we just called plt.title and then to that passed some string. So the difference now that we're working on the actual subplot objects is that we have to call set underscore first, and then comes whatever we want to change. And again, when we now look at the syntax, we see that it's quite repetitive. So we have to call x every time and also write set every time. And so whenever we see something like this, there's usually a better syntax. And indeed there is. Instead of calling x.set something multiple times, we can call once x.set and that to that pass keyword arguments where the keywords are what we want to change and then the values are how we change that. So instead of writing x.set underscore title, we just put title in here as a keyword argument, and then here we have the title. So this achieves the same thing, but shorter. Okay, so much for the underlying structure of matplotlib. Next up, we'll check out the plotting functions of matplotlib. So last time we covered some really basic ones, but of course there's a lot more. So here in the basic section, we have a line plot, scatter, bar, stem plot, and much more. And this is just for basics. So besides that, we can also plot two-dimensional data and also vector fields. And we can also do statistical plotting. So histogram, box plots, or violin plots. And in this video, we'll of course not walk through every single one of them, but you can check out the matplotlib website. And if something looks interesting, you can just click on it and then copy paste the code. And now you should also be familiar with all the syntax. So here you can see we are creating figure and axis object using the plt.subplots function. And then on the axis, we're doing some plotting. And then here we're using the .set function to change how our plot looks like. So we'll not go through all of these, but what we will cover are some interesting code pieces. So for example, when we're dealing with bar plots, we can change the color of the bars based on some condition. So we create our figure and axis, and then on our axis, we create a bar plot. And from this bar plot, we can access the different bars. And together with the bars, we zip our y data, and then we use the y data to check if it's smaller than 0. And if it is, then we set the color of the bar to red. And this gives us then this plot here. Another cool feature, which you might have seen already, is that we can use imshow to display images. So the imshow function expects an array, but because when we load our image that's already in form of an array, we can plot that easily with the imshow function. Another useful thing is that when we have high dimensional data, which would be usually very hard to plot, but we can represent the different dimensions through the different aesthetics of our plot, such as color or size and shape. So we have here this three-dimensional function, which is based on x1, x2, x3. And x1 is on the x-axis, y is on the y-axis, but then x2 and x3 we represent through size and color. So you can think of them as just another axis, which actually makes sense if we look on the right side here where we have this color bar, which we create by passing our plot to the fig.colorbar, and this is basically an axis. And so now if you want to find out more about these aesthetics, so for example, how to change colors, or how to change the markers, or line styles, and also how to add text or even math text to our plots, then you can read through all that. Here's also some stuff on limits, legends, and layouts, and also tick lines, tick labels, and tickers. And of course, we don't actually recommend you to read through all of that, but rather to scroll through it and get a good idea of what is possible in matplotlib. And then whenever you need some functionality, you know it's there and you know where to look it up.